Good morning, guys. So this morning we have a board to work on. This is a 15-inch touch bar model. This is a late 2016. The model number on it is A1707. And the issue this one is having is seems to be more and more common. We've gotten a couple of these in that it's not charging, and I'll just show you that now. We do have our adapter, our charger that has the amp meter, and we're going to take our charger connector, our USB-C charger cable, and just plug it into the board here. And I'll show you what we get. So we're going to take the cable, just plug it in where it goes, and we're going to plug in our charger now. You can see here we're getting 5.03 volts, 0.23 amps. See, our voltage there is supposed to be around 20 volts, and we're only getting 5. So I don't know if you remember, but from our 12-inch MacBook that we repaired was having the same issue. It would get 5 volts on the input to the 20. And so a lot of times this has to do with our controller chip, or the MUX chip. Remember, like I explained in the 12-inch MacBook, that had only one of these USB-C ports. This is your input for your data and output data, and also this is going to be where you charge your unit. So the same connector here does everything. It does all your inputs, outputs, and your charging. So in order for the machine to know whether to send the voltage to the battery to charge it, or to the machine to power it on, or to the chips to process the input of like a thumb drive or a hard drive or something that's plugged in externally, it has to have a controller chip or a MUX chip that sends the signal to the correct place. With this showing only 5 volts, typically that's going to be the problem, is your controller chips are not going to be working. However, with this model, we have 2 inputs over here, and when this cable is plugged in over here, we also have 2 inputs on this side. So we have 4 USB-C ports on this machine in all. And in order to control all 4 of these ports, we have 4 controller chips. And the bad thing about this machine that makes it a little bit more complicated is all of these USB-C controller chips are all tied and linked together. So when you have a problem like this, you don't know exactly which chip is bad unless you have like an infrared camera that can see the temperatures of the board. It makes it a little bit more complicated to do this, and unfortunately we don't have one of those. So we're going to have to play the guessing game, I guess. First off, what I like to do is just plug in the power where we had it, and feel around on the board and see if we can find any parts of the board that are hot, and hopefully we can narrow this down. So we'll let that power back on. I also like to get a rag with some alcohol, and we can touch these USB-C controller chips to see if we're getting any heat on any of them. So here's one right here, and it's evaporating about normal. So that's probably a good chip, we're guessing. We're going to flip it over, and the other side of the board has another controller chip. Right here. It's evaporating a little bit quicker, but it's still not super fast. Alright, so let's plug this in on the other side of the board. And on this side of the board, both of the USB-C controller chips on the back side. Right here. So we're going to take the alcohol again. Let's get a little bit more on there. Yet again, they're not evaporating any faster than normal. Okay, so we're going to move on to the next thing. As you see, we're on this side, we're also getting 5 volts. Back it up just a little bit. Getting 5 volts there. And on this one, what are we getting? 5 volts. And let's flip over the board and go to the other side again. Okay, it's not even turning on. Try this one. Oh, came unplugged. Okay, that's powering on. Still 5 volts. And that port is not even powering on. So that might help us be able to narrow down which chip is bad, possibly. Alright. Well, let's take a look here. Fortunately, I have a donor board. And so this donor board, let's plug it in and see what voltage we get in this one. See there, we're getting 19.8 volts, which is what we're supposed to be getting. So this, let's just go ahead and try all of them to make sure. Yep, 19.8. On this side. .8, and this one powers on too at 19.7.8. Alright, so all these chips are reading properly. So that's good news. So what I'm going to do first, since we're having issues with that one port, I'm going to take a look with the multimeter and see what we can find out. So we're looking at, I believe, this chip here. We'll check this one out first. And I'm going to check it out with the multimeter. So what I'm going to do is show the multimeter. Get a better view here for you. I'm going to check for a short to ground first. Oops. Okay. And I'll show this under the microscope. Alright, so here's our donor board. And we're looking at this chip here. Get it flat. Alright, so this is our controller chip. Let's just look up on the schematics here. First we'll look at the board view. And so here we have the board. Let's flip it over. And so we're looking at this chip right here, U3100. And so we'll look at that on the schematics. Do a search for U3100. Alright, so you see here it says primary ACE USB-C port controller for our USB-C. Alright, So this is the chip we're looking at here on the board. And pretty much, I mean, you can find this, I've already done this board before, so I'll just show you. You can find this chip on the front page of the schematics. Granted, it is 120 pages long, so you have a lot of stuff to look through, but over here on page 30 and 31, you'll see where it says USB-C port controller A and port controller B on page 31. And then also, for some reason, they put it completely separate in the schematics. USB-C port controller A and controller B, that's because the other two ports are over here. So right now we're looking at U3100 on this part of the board over here. So that's what we're going to look at now under the microscope. And I'm just going to check these capacitors to see if we have any short to ground on any of them. Just make sure we're going to get proper readings. And let me actually put the bad board up here first. And we're just going to check and see if we have any short to ground. So if we get a reading of 0 on this resistance mode, we know we have a short to ground. So I'm going to take the red probe and put it on ground and just check the capacitors. So you see the capacitors are here, 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 and here. These look like the biggest capacitors of the bunch. So we're getting a proper reading there, I believe. We'll check it here in just a minute with the other board. The 0.3339 or 0.339. And then this one up here. .120. That's kind of low from what I believe. I mean, that's kind of low. Oh, and here we got a, yeah, we have a short to ground on this capacitor. So this may be the problem. It may be the chip. It may be a bad capacitor. Let's check it with our donor board, and just to make sure. And we got the same chip. Red probe on ground. Yeah, I mean, it's supposed to be 0.491 instead of 0.0. So that's the problem with our board, probably. And this was 339, which that's kind of close. And this was 0.12. Yeah, that's right as well. But this one right here is not supposed to read the ground. All right, so in instances like this is a BGA chip, which means a ball grid array. There's a lot of solder balls underneath this chip, and if I remove this, I'm going to have to end up reballing it to put it on the new board. So what I'm going to do, since we have a short to ground on this capacitor right here, I'll show you that again. I have a direct short to ground. It's 0.000 resistance to ground, so it's direct short to ground. I'm going to remove this capacitor, and then we'll check it again just to see if we still have a short to ground. And if I remove this capacitor and it's gone, then we know the capacitor is bad. So let's go ahead and remove the capacitor. Let's look on the board view real quick and just see what that is. So it's that cap right there. And you can see how it ties in. See, one side is ground, one side is not. This is a data line, or actually a power line, the 3.3 volts, 3V3. So when a capacitor goes bad, instead of giving, what a capacitor does, it makes the energy think that it's going to go to ground, but it doesn't allow it to go to ground. So there's no short to ground in this. It's supposed to be. But if a capacitor goes bad, it gets a short to ground, and all the energy goes directly to ground, therefore not powering the rails like it's supposed to. So it could be this capacitor, or it could be this chip here. See, this could be, the chip could be short of the ground. Or you see how there's a ground pad right next to these pads. There might be something connecting these, liquid damage or something that's connecting these and shorting that to ground as well. But first we're going to remove this capacitor and see if we have a change. Let's hope we do. And by looking at it, you can't see anything wrong with the capacitor. So we'll just see what happens. Alright, let's check that pad and see what we get. Looks like we still have a short to ground. Unfortunately, I believe. So what we're going to do, we're going to remove this chip and see if we still have a short to ground there. So let's go ahead and do that. When I take out the chip, I like to look on the other side of the chip. It does look like it's been liquid damaged a little bit, but it doesn't look bad. I mean, I don't see any burn marks. Alright, anyways, we have the chip off now. Let's take a look and see if we still have our short to ground on that rail. Oh, look at there. No short to ground, it's actually an open line now. So that was our problem the whole time, is that chip. So now, let's go ahead and clean the pads up. I'll get you a better view on the camera here. Alright, so we're going to clean these pads up, so we'll put some Flux on, and I'm going to turn on my filter. Going to put some leaded solder on. You must turn on your soldering iron when you want to use it. Alright, so let's go ahead and move over that capacitor so we don't forget to put the capacitor back on. So now we're going to take off our controller chip from our donor board. It's much cleaner than the other one, I do have to say. Alright, so we're going to clean this chip up. And we're going to reball it. So first going to put a little bit of flux on it. And we're going to put some leaded solder on there. Okay. I'm going to clean the chip up now. Clean the area we're going to be using, because reballing it is very tedious and you want to make sure you get it right the first time. Turn that off for now. It's kind of loud. Alright, now with these, unfortunately I don't have a stencil for it, so what I have to use, what I've been using, hey, go ahead. What I have to use is this is from an iPhone 6 Plus stencil. And so, yeah, so I found a stencil that matches pretty closely. Now, the fun part is getting this on the stencil and keeping it in place. So you can kind of feel when it fits in place. It won't slide. So what you have to do is get some Captain tape. Cut a piece of it out. And put down over this chip. And just see how it lines up. Hey, we did pretty good. That is not too bad. Alright, so I think we're good there. So now I'm just going to tape it down. Like that. Tape it down to the stencil. And chip it out again. And, I mean, we're pretty lined up there. It's not too bad. So now, we take some of our solder paste. And get this tool, this flat tool. And we're just going to spread on some solder paste. Just like that. And then we can wipe up the extra. So now we have solder paste in there. And we're going to heat this up and melt that solder paste. Heat up the whole area first. If you heat it up too fast, and it's just going to blow out. So you just want to do it nice and slow. Just like that. Alright. Now we're going to let that dry for just a second. Pull down. Remove the tape. some alcohol in there. Cheers. Check it out. Looks good. You see a little bit squeezed there, but we can clean that up. Should be no problem to clean this up. A little toothbrush and alcohol. You can see the flakes just come off. Get out of there. There we go. Alright, so it's reballed. And looks pretty good. So now what we have to do is put it on our board. Clean up this area. Clean up our board a little bit. Gonna add some fresh flux. Alright, so now we see the orientation of the chip the way it's supposed to go. There's a ball missing right here, and so we want to make sure that we get that same pattern. So when we flip this over, it will match, just like that. Alright, and we're going to eyeball this. This is also not fun. So we're talking about right there. Alright, it's got a little bit of melting going on. Add a little bit more flux to the area. And then slowly heat it up. And you should see it flow into place when it melts. There we go. You can see it dancing around. So it should be good now. Let that cool off for just a moment. Before we go any further, we're going to check this or short the ground again. And let's see what we get. There you go. And we don't have a short to ground. We've got a correct reading now. So guess what? We should be reading or pulling 2 or about 20 volts on this now when we plug in the power adapter. So let's check it out. Let me get my desk cleaned off. Let's go to the full view here. Plug in our cable. And our charger. There it is. There it goes. And what are we getting? Can you see that? Can you see it? We're getting 19.8 volts and 1.63 amps, 1.48. So we have the machine powered on now. Now let's check the other test. Remember, this other port up here was not even powering on. And we have power now. And 19.8 volts with 1.45 amps. So we have the machine powering on now. So that was our problem the whole time. So this took a little diagnosing. I'm still learning these boards as well. The schematics are a lot different. The names of the powers, the rails, just the names of everything are different. So I'm in a learning process as well, but it just takes a little diagnosing to figure out what's going on. We were able to troubleshoot it and repair it, and now I just got to put it in the cleaner and clean this chip up and get it installed back into the machine and make sure we have the machine powering on, which I'll do, and I'll show you that as well. So I'll be back in just a moment to show you that it's powering on. Looks nice and clean. Got all the flux off. So we're good to go. So now let's install it into our machine and check it out. Okay guys, well, we have it back installed into the machine here, and we're going to plug in our power adapter and see what we get. Powering on, this is the one that it wasn't powering on earlier, and we see we have a fan spin too, and it sounded like the chime, or not the chime, but the battery charging indicator. Alright, let's open it up and see what we get. See if we get anything on the screen here. Oh, I have an Apple logo. And we have a boot up screen. This is the login screen. So we are good to go. We have repaired this touch bar. So that's some good news. Alright, so now we've shown how we kind of narrowed down the issue. We've did some troubleshooting, followed the schematics, the board view to figure out what was wrong, and fortunately it was just one chip we had to change. The last one I did of these, I had to change all 4 chips until I got the correct one. It may have been all 4, but I highly doubt it. It was probably just one, and I ended up replacing all 4 of them. It ended up being the very last one that I replaced. But this one's good to go. We're going to do some more diagnosing on it to make sure everything's working, but board's working so far. So anyways, that's it. If you have any questions, make sure you leave some comments down below. If you enjoyed the content, subscribe, give us a thumbs up, and hope you have a great day.